The main idea behind balancing of chemical equations is to make the reactants have the exact same number as that of the products. Now, before we proceed with balancing chemical equations, let us consider some few facts about balancing of chemical equation. So the first thing we need to know is that in balancing, change only the coefficient, not the subscript. The subscript is basically the lower number attached to each element in the reaction or the equation. So over here, the product side, the subscript of oxygen becomes 3. That of aluminium becomes 2. At the reactant side, the subscript of oxygen becomes 2. And aluminium becomes 1. Although there was no 1 attached to aluminium, but anytime an element has no subscript, it is considered to be 1. For the coefficients, they are actually the numbers that appear in front of the element or compound in the equation. So at the reactant side, the coefficient of aluminium becomes 4. That of oxygen becomes 3. And aluminium oxide at the product side becomes 2. So basically what we need to know over here is that the subscripts can never be altered, but the coefficients can be altered anytime to make sure that the whole equation is balanced. Another thing we need to know is that anytime you multiply the coefficient by the subscript, it yields the number of atoms. So for example, to determine the number of atoms of oxygen on the reactant side, we multiply the coefficient, which is 3, to the subscript, which is 2, and it yields 6. To determine the number of atoms of aluminium at the product side, we multiply the coefficient, which is 2, to the subscript, which is 2, and yields 4. And that is that. Secondly, always start balancing all other elements, leaving hydrogen and oxygen to be the last if present. The reason is that if you start balancing with oxygen, you can end up screwing up the whole equation. But when you leave oxygen and hydrogen to the last, it makes the balancing process a bit easier, because most of the times oxygen and hydrogen tends to be balanced at the end of the reaction without touching them yourself. So make sure you leave them to the end before you balance them. Finally, balance polyatomic ions that cross from the reactant side to the product side unchanged as a whole. Do not separate them. Common example of polyatomic ions are SO4 2-, OH-, and PO4 3-. Alright, so let's get started. So over here, we have an unbalanced equation. Our first step is to write an inventory of all the elements we have at the reactant side and all the elements we have at the product side on either sides of the equation. So beginning from the reactant, the inventory of the reactant becomes CH and O. For the product, it also becomes CH and O because those are the elements we have. Now, as you can see, I've written the inventory in the same exact order. This is to make the balancing so easy and simple. Now let's get back to our reactant and see how many of each reactant we have. For carbon, we have a single one. For hydrogen, the 4 attached to the hydrogen shows we have 4 hydrogen atoms. Oxygen, we have 2 oxygen atoms. At the product side, we have a single carbon atom. We have 2 hydrogen atoms. For the oxygen, we have 2 of them in CO2 and a single oxygen in H2O, giving a total oxygen of 3. So the oxygen atoms at the product side becomes 3. Considering the inventory, carbon is already balanced since it's one at the product side and one at the reactant side. So we start from hydrogen and ends on oxygen. For hydrogen, it's 4 at the reactant side and it's 2 at the product side. So definitely we need to balance the product side so that it becomes equal to that of the reactant side. Since we cannot change the subscript 2 next to hydrogen to 4, the only thing we can do is to multiply by a number that can make hydrogen 4 in H2O. And that number is 2. So you multiply gently by 2. Or multiply by 2, it makes hydrogen 4 because 2 times 2 yields 4. So hydrogen no longer becomes 2 but 4. In the same way, the 2 that has been multiplied to the H2O changes the identity of oxygen. It makes the oxygen atoms in H2O also 2, giving a total of 4 oxygen atoms at the product side because there are 2 over here and 2 over here. Combining them, we get 4 oxygen atoms. Looking at the reactant side, oxygen is 2, so it needs to be balanced. Since we cannot change the subscript 2 attached to the oxygen at the reactant side, we still need to multiply by a number. So multiplying by 2, we end up getting 4. And the number of oxygen atoms at the reactants become 4. Now our equation is balanced. Let's consider a new example. Over here, our inventory has already been written. Looking at the equation, we have a polyatomic ion in there, and that is the SO4 ion. You realize that it remains unchanged when it moves to the product side. So at the reactant side, we just have 1 of it, and the product side we also have 3 of them. So SO4, the brackets there means that the 3 is affecting all the elements in SO4. So because it moves from the reactant side to the product side unchanged, it must be considered as a whole without separating it into sulfur and oxygen. So looking at our inventory, realize the very last one has SO4 over there. So this for the reactant side and this for the product side. So we do not separate them because they move from the product side, the reactant side to the product side unchanged. So at the reactant side, aluminium is 1, chlorine is 3, hydrogen is 2, and the SO4 over there we have 1 of them. At the product side, we have 2 of the aluminium. Chlorine is 1. Hydrogen is also 1. And we have 3 of the SO4s. So 3 of them. So this is it. Looking at our inventory, realize that everything is imbalanced over here. So we need to start balancing everything. So getting back to our reactant, aluminium is 1 over there, and at the product side is 2. So aluminium got to be balanced. To make aluminium 2 at the reactant side, the only thing we have to do is to multiply aluminium chloride by 2, since we cannot just fix 2 as a subscript next to aluminium. That isn't accepted. So when I multiply aluminium chloride by 2, it changes aluminium from 1 to 2. Again, aluminium chloride has aluminium and chlorine. So since the 2 affect all the atoms in there, chlorine now changes from 3 to 6. Because the 2 multiplies the subscript there to yield the number of atoms of chlorine there. So no longer 3, it changes to 6. Let's get back to the product. Chlorine is 1 and the reactant is 6. So it needs to be balanced. So the only way chlorine can be balanced at the product side is by multiplying HCl by 6. So when we multiply HCl by 6, it changes Cl from 1 to 6. But multiplying HCl by 6, the 6 also affects the hydrogen atoms as well. So the hydrogen atoms in HCl changes from 1 to 6. But watch here, the H at the reactant side is unbalanced. It's 2. So it also needs to be balanced. So the only way we can do that is to multiply by a coefficient that can yield 6 atoms of hydrogen, but not to change the subscript 2. So either 6 or any other number. So to get 6 over there, the number we can multiply by 2 to get 6 is 3. So we multiply the whole H2SO4 compound by 3, like this. And that makes the H atoms over there 6, since the coefficient times the subscript yields the number of atoms. So hydrogen changes from 2 to 6. So hydrogen atoms are also balanced. Now let's get back to the SO4s. Multiplying H2SO4 by 3 does not only affect the hydrogen atoms, but affects the whole of the SO4 molecule in there. So it changes the SO4 molecule in there from 1 to 3. So it no longer becomes 1, but now 3. Great. So let's check our inventory once again. Aluminium is 2 at the product side and 2 at the reactant side. Chlorine is 6 at the product side and 6 at the reactant side. Hydrogen is 6 at the product side and 6 at the reactant side. SO4, 3 at the product side and 3 at the reactant side. And that makes our equation balanced.